Welcome back to PV Online. Today we're going to continue our discussion on kinematic calculations. All right, so we have our example here. Now remember, it would be wise to have the three kinematic equations written out. So I would have this on a sheet of paper. This top one is going to work for any condition, and the second and third one is going to work anytime your initial velocity is going to be 0. So as long as our initial velocity is 0, these two are going to work out fine. All right, the question is, it says what distance? So right off the bat, that's telling me I'm looking for the distance. That's what I don't know. And it says it's required for a train to travel if it starts from rest. If it starts from rest, that tells me my initial velocity is 0, which is good because then that means that these two equations will be fine, will work fine. And it accelerates at 0.25 meters per second squared. Remember that the unit is a guide. Acceleration has a unit of meter per second squared. So that means the number that I'm going to put in wherever a goes is 0.25. And then we have 120 seconds. And 120 seconds is going to be time, and I know that because of the unit. All right, so we have our variables. I've listed everything of importance. This is 0, so I really don't worry about him. And so I want to find out the distance. So we have to come over here and choose between these three equations. So now let's take a look at this. Would one be satisfactory? Could I solve for distance with this one? And the answer to that is no, because there's no distance in the equation. So let's go down to our next one. All right, I've got a distance here, which is good. 1/2 is just 0.5, so that's not anything I worry about. Do I have the acceleration? I do. Do I have the time? I do. That means that this second equation will work just fine. But let's just take a look at this third one. I can't use this equation because even though it's got a d inside the equation, I'm not given anything about a velocity. So this one's not going to work, neither will this one. So we're going to start by writing that the distance equals 1/2 the acceleration times time squared. So now all we need to do is substitute in the numbers for the letters. I'm looking for distance, so I'm going to keep that as d. 1/2. If you don't like fractions, make this 0.5. So I have 1/2. What number am I going to substitute in for a? Because I know the value of the acceleration, and that is 0.25. Don't include the units here because it'll get too messy and it'll confuse us. So that's 0.25. What number do I substitute in anywhere there's a t? And I'm going to put in 120. Again, I'm not going to put the unit. Now, the one thing you have to be careful of is we have to square that. So in our calculator, I'm simply going to multiply these across. I'm going to take 0.5 times 0.25 times 120. I need to square it, so I have to multiply by 120 again. I do this and I'm going to get, and I get 1,800 meters. All right, let's do another example. All right, once again, I've got our three kinematic equations. And I'm going to start from the beginning. It says a person starts from rest, so that means my initial velocity is 0. And it accelerates at a uniform rate of 3.2 meters per second squared. I know that's the acceleration, both because it tells me it's the acceleration and because the unit is meters per second squared. So I have that value. For a distance of 150 meters, that's going to give me the distance is 150. And the question is, how long did it take? And I'm looking for the time. How much time is it going to take for us to go that distance? So we go through our three kinematic equations, and my initial velocity is 0, so that means I can use the second and third. I'm looking for time, so that's good. I've got the acceleration. My initial velocity is 0, but I don't know the final velocity. This equation won't work. As soon as you have two things that you don't know, two unknowns, that equation's not going to work. So let's go down to this next one. We've got the distance. That distance is 150. 1/2 is just a number, 0.5, so that's never going to change. I know the acceleration, but I'm looking for time. So this is going to be perfect because I have the one unknown. So we're going to use our distance equation again. So I have 1/2 times acceleration times t squared. All right, our distance was 150 meters. That equals 1/2 times my acceleration, and my acceleration was 3.2 times time squared. These terms are all multiplied, all right? So I'm going to take 150 and we'll take what's 1/2 of 3.2, and that's going to give us 1.6 times t squared. All right. I want to get t all by itself, so I'm going to divide both sides by 1.6. And that will give me that t squared equals 93.75. So my calculator says 93.75. But I want to get rid of that squared. I want to find out what t is all by itself. And the way you do that is by taking the square root of both sides. So I'm going to take t equals the square root of 93.75. So you'll need to find that button on your calculator. And I get my time is going to be 9.68 seconds. And that seems reasonable because we know the square root of 100 is 10, so we can kind of approximate that and go, that sounds pretty good. All right, we'll see you next time.